Hello everybody and welcome to another session of data analytics. Today we'll be using data science to solve digital marketing concept, and basically we'll be using explanatory data analysis. Now what is digital marketing? Digital marketing is when actually firms or companies are trying to move towards online platforms such as Facebook or YouTube, and they advertise all these online advertisements regarding football, regarding news, regarding products you buy. This is all known as data analysis. However, in reality, it's quite vital for companies to understand that how do consumers or how do users react to their data, or how do the users react to the advertisements on the net. So the content for the day will explain elaboration on how structured data was created, discussion about the quality or transformation issues that we face during the creation of the data, such as errors, outliers, missing data, and the techniques that we use for identifying and addressing the problem, and followed by visual representation of gender distribution, number of clicks, click-through rate for the 7 age categories. These are the age categories. They start from below 18 and above 65. And above 65, we'll analyze each segment through mean, median, quantile, maximum, and minimum. So the objective that we are facing at the moment is that we have been hired by the editor of New York Times. Our job is to analyze the company's digital marketing data. And for this we were provided a data set, 31 data set from the file name NYT1 to NYT31. All of them are Excel files, and each Excel file represents 1 day's worth of the ads shown and clicked on your Times website. So basically, each data set actually showed the whole thing in a day, that how many ads were uploaded on the server, and how many ads were clicked on, how many users clicked on the ad and they liked it. And the dataset contains information such as age, gender, number of impressions, number of clicks, login status. Now I know it's a bit confusing, but it will be explained further later. It will be explained further in the slides. So now as you can see that now the method that we used for analysis method that we used in this was descriptive, because we are describing, we're not predicting anything, we are just using of what happened. Descriptive analysis focuses on the past. So now we use descriptive analysis to understand what actually happened. Now, descriptive analysis is a brief descriptive coefficient summarizing given set of data, or the data can either be a representation of the entire population or a sample of it. Now, for example, we are only using one data set included of 450,000 records. However, we are only using a sample of it, which is 20,000. So basically, we can either use it on the whole data, or either we can choose a random sample and work on it. So now there are two things. Now there are two ways, and there are two methods in descriptive statistics, which is central tendency, which and mean, median, mode, and standard. These things come under it. Whereas measures of variabilities, because they keep on changing, they're variables, and standard deviation, minimum, maximum, these are the variables, and the kurtosis and the skewness. As you can see from the diagram, this is what a typical descriptive statistics looks like after calculation. For example, let's say that this is understanding of the population, and you can see where the mode, the median, and all of this five. So let's proceed to the next part of the presentation.
Hi, Mr. Yakub. Today I'll be talking about question 2, assignment 2 on how I group up all the edge in the Excel sheet. First, I use the if statement to group up all the 7 different types of edge group. Once the if statement is done, the Excel file will look something like this for the edge group row. As we can see, there are lots of edge that has 0 value. We do not want that, and we want to remove it. So first, we go to the filter in the Excel sheet, and then it will generate something like this. So in order for us to delete all the value that has 0, we can just filter out the 0 value and delete it. But since we have a data that consists of 300 to 400,000 files, some file even have 700,000 plus data, we cannot delete it directly because the Excel file will stop responding and freeze. So in order for me to do that, I need to create a new index row that will have a sequence of 1, 2, 3, 4, 5, 6 and so on. And once this part is done, we can go to the edge and then we can sort the number from smallest to biggest. After the sorting is done, now we can filter the 0 edge value only and delete it. After we have deleted the 0 value, the data will be arranged from smallest to biggest. It will look something like this. But in order for us to revert back to the original state of the view, we can go to the index and we click sort from smallest to biggest so that in the end the file will look something like this.
Hello everybody, my name is Abdul Basit and I am going to talk about data transformation issues and techniques used for identifying and addressing these problems. This all come under data exploration. Data exploration is the first step in data analysis and typically involves summarizing the main characteristics of a dataset. It is commonly conducted using visual analytics tools, but can also be done in more advanced statistical software. The first step is variable identification. First, we identify predictor and target variables. Next, we identify the data type and category of variables, which in our case, predictor variables are age, gender, and impression. Target variable is number of clicks. Under data type and character, there is gender and age group, and numerically it is number of clicks, logged in status, and impression. Then comes variable category. In categorically it is gender, impression, and click-through rate. Lastly, continuous. It comes age, logged in status. Now we move on to univariate analysis. At this stage we explore variables one by one. Method to perform univariate analysis will depend on whether the variable type is categorical or continuous. For our case, we have used continuous variables. Under central tendency, we have mean, median, quartile 1, quartile 3, minimum and maximum variable. Then measure of dispersion, we have taken IQR. Moving on to visualization methods, we used clustered column chart, 2D pie chart, 2D line chart, and stacked column chart. Now we move on to missing data. Missing data is defined as the data value that is not stored for a variable in the observation of interests. In statistics, missing data or missing values occur when no data value is stored for a variable in an observation. Missing data are a common occurrence and can have a significant effect on conclusions that can be drawn from the data. The problem of missing data is relatively common in almost all research and can have a significant effect on conclusions that can be drawn from the data. Accordingly, some studies have focused on handling the missing data, problems caused by missing data, and methods to avoid or minimize such in medical research. However, until recently, most researchers have drawn conclusions based on assumptions of a complete dataset. The general topic of missing data has attracted little attention in the field of anesthesiology. Missing data present various problems. First, the absence of data reduces statistical power, which refers to the probability that the test will reject the null hypothesis when it is false. Second, the lost data can cause bias in the estimation of parameters. Third, it can reduce the representativeness of samples. Fourth, and lastly, it may complicate the analysis of study. Each of these distortions may threaten the validity of the trials and can lead to invalid conclusions. Now let's identify the reasons for occurrence of these missing values. They may occur in two stages: data extraction and data collection. Data extraction: it is possible that there are problems with data extraction processes. In such cases, we should double check for correct data. With data guardians, some hashing procedures can also be used to make sure data extraction is correct. Errors at data extraction stage are typically easy to find and can be corrected easily as well. Data collection: these errors occur at time of data collection and are harder to correct. They can be categorized into four types: missing completely at random, missing that depends on unobserved predictors, missing that depends on the missing value itself. We have missing values due to data collection. Our data is missing at random. This is a case when variable is missing at random and missing ratio varies for different values or levels of other input variables. Like for example, we are collecting data for age and female has a higher missing value compared to male. That is a simple explanation, like an example. Sliding on to treating missing values. Deletion. It is two types of deletion: listwise deletion and pairwise deletion. In listwise deletion, we delete observations where any of the variable is missing. Simplicity is one of the major advantages of this method, but this method reduces the power of model because it reduces the sample size. In pairwise deletion, we perform analysis with all cases in which variables of interest are present. Advantage of this method is it keeps as many cases available for analysis. One of the disadvantage of this method it uses different sample sizes for different variables. Deletion methods are used when nature of missing data is missing completely at random, else non-random missing values can bias the model output. Lastly, let me explain you procedure we use to delete missing data. First, we use the unfiltered data, including the missing values, and opened it in Excel file. Then we click the filter button and choose 0 uh, we choose the 0 using a drop down menu. Then we highlighted the data that we all needed, in which we can use 1%, 2%, 3% of data that we have. And then after highlighting the data, we right click and we delete the row. That is all from me. Thank you very much.
Hello everybody, welcome to this phase of the assignment known as the analytic plan phase. Now in this part we will discuss in depth about the analytic plan which we draw from the data. So now the first step in an analytic plan is to problem frame. Our problem right now is to analyze the click-through rate of users according to age group and figuring which age group is likely to visit more based on ad impressions and clicks, and how will it help to successfully evaluation and assist New York Times in targeting most profitable age segment and enhance their digital marketing strategy. So now we have our initial hypothesis are five. Now hypothesis is just a statement that can be true, that can be false. If it is true, it's okay, but if it's false, it doesn't matter. It's just there to prove something. So now our first hypothesis is that male demographics are more a potential target segment. Possibly right, possibly wrong. Our second hypothesis is that female segment has higher probability of ad clicking due to high ad impression. Maybe the ads were more, maybe our female audience prefer, well, the ad was more appealing to the female audience. The age group below 18, 55 to 64, and 65 plus for both genders have a high click-through rate. The fourth hypothesis is actually all users use frictionless login method to sign in. What's their Facebook account? Now, frictionless login is basically when you have already logged in into Facebook, but then you are moving on to another page and they ask you to sign in with Facebook or maybe sign in with a Google account, and then you just click it on Facebook. But since you're already logged in Facebook, it automatically logs you onto that account. So basically, which means that most of them they had a Facebook account which they already logged into. And the fifth hypothesis is advertisement nature attracts female more than males, as we discussed above, which is that it's somewhat similar to hypothesis 2. So let's move on. Our data and scope. Now, data and scope is basically talks about what kind of data we use, and as discussed before, our data that we use was the 31 dataset files provided by New York Times, which comprised of age categories, the gender, ad impression, amount of clicks, how many clicks, 0 click, 1 click, 2 click, 3 click, and the click-through rate. Now the formula to calculate the CDR is actually total measured clicks divided by total measured ad impressions, and then you multiply by 100. It is expressed as a percentage, so for an easy use of 100 is added to above equation, because most of the times the number of clicks are less, or the number of ad impressions outnumber the number of clicks, and the data, and when the answer that we get is actually in decimals and it's too small. Sometimes it's pretty, and if we use that information to explain, it becomes quite hard to explain, and it actually doesn't make sense for the user or for the viewer to understand how many percent does it make. That's why we add 100 at the end. So now what does it mean? Total measured clicks is the total amount of clicks on an ad which were counted by a server. So every time you click on an ad which you watch on a server, the server counts at 1. Total measure of ad impression is the number of times an ad was loaded on a page and counted by a server. So for example, let's say you are browsing through a web page and you see an ad. So every time that ad loads up on the web page, every time the server counts it that the impression has been made. Now, if we click on the ad twice, it's going to count as 2 clicks. If we click on the ad once, it's going to count as 1 click. However, no matter how many times you restart or refresh the page, every time that same ad loads onto the page, every time it makes an ad impression. I hope you understand well. Now, model planning, as discussed before, that we use descriptive analysis to evaluate our method, and such as mean and median, quantile range, which includes quantile 1 and 3 and 2, and maximum and minimum. So the result and key findings are that when we discuss about our data, according to a gender distribution by age, as you can see that male outnumber female, but except for this age group. In this age group, females outnumber male, which means 65 and above. According to the total measured ad impression by gender, most of the ad impressions made on males, as you can see. Again, the age group 65 plus is where females outnumber males quite a lot. Whereas, if you look at the total clicks by gender, you can see this trend that for males, even though it's pretty high in the beginning, but it keeps on dropping down, and it suddenly picks up pace from this age group and up to 55 to 64. It's going pretty well, but it drops down. As for the female, it's a steady and constant rise for every age group. There are no downfalls. In fact, it keeps on rising and rising. So which means that we can say that females had a higher click rate in all segments compared to males. For the males, the total clicks were actually high for this age group and this age group. For these two age groups, they weren't that much interested in the advertisement. So which means that the advertisement in nature was more appealing, as we said before, was more appealing to the women audience, to the female audience. Now this is the CDR rate for both male and female. As you can see, the biggest section in this for male is the below 18 one, because it ranks 25%, followed by the 65% for male. Which means that these two segments they had the highest CTR rate, which means they were the ones that most impression was made upon, and they are the ones who made the most clicks. The least session in this one is these two, 25 to 34 and 35 to 54. They didn't click on the ad that much compared to other age groups. Now, if you look at the female, over here, it's a quite opposite. See, the 65% takes the lead, whereas the second one, with below 18, takes the lead as 23%, comes in second place. So in both sections, you can see that the below 18 and 65 plus to take the lead in terms of CTR rate, click-through rate. And again, over here, or the lowest group is actually 35 to 44. They have the 7%. The 7% of those actually had a click-through rate, which means that in both segments, 35 to 44 was the least profitable, and these two, the below 18 and 65 plus for both age groups, was the most viewed or most ad impression made group. Now we actually move on to the mean median mode. As you can see, we are calculating the click-through rate, the impressions, and the clicks for all the age groups for both male and female. Now the mean, as you can see, is that the mean click-through rate was 1.7 for male and 1.76 for female, which means that the mean for male is quite high compared to female, whereas the median over here is 1.18, but for female is 1.2. So in this case, the female median rate is higher. If you look at the quantile range, the highest quantile for 1% is 1.076, whereas it's 1.09. Quartile 2 is 1.18, whereas 1.2. And quartile 3 is 2.5, where for female it's 2.4. So as you can see that in these two, for quartile 1 and 2, both males are quite higher compared to females, except for quartile 3, where male outnumber female. And for the maximum number or maximum CTR in for our male is 3.1496, which we can find over here, and the minimum is 0.9. Whereas for female, it's 2.0. The maximum is 3.0, whereas the minimum is 0.09. In terms of impressions, the mean is 7,444. As for the female, it's 6,942. The median is 7,625, where the median for female is 6,418. The quartile 1 over here is 4,900, where it's 5,900. The female outnumber male. However, quartile 2, the males outnumber female, and in quartile 3, again males outnumber female. The maximum over here is 11,000, while the minimum is 3,000, and over here the maximum is 10,000, where the minimum is 1,449. Now the business impact. Now how is this going to have a business impact on New York Times? See, effective digital marketing for New York Times, because they will be able to understand the nature of their customers, and they'll actually modify their advertisements to users' taste or preference. So now, as we can see, that females had a higher click rate, which means that the advertisement was more female friendly, and it appealed to the female audience. So basically, it means that next time, next audience, or the next advertisement that New York Times will promote, they'll be able to actually design the advertisement in such a way which actually appeals to the target audience. So if they're focusing on females, they'll make it more female friendly, or if they're making it a unisex advertisement, they'll actually make something which is acceptable by both genders. Enhances customer segmentations in form of subscription and login status. And so basically they're able to understand how many customers out of these are likely to subscribe, and how many of them are using logged in status. Are they just logging into their website as guests or users? And finally, they'll be able to develop a mobile-friendly application for effective customer base. Now everybody's using smartphone these days, and everybody has data with them. So to be able to click from different location regardless of time, everything, it's a good opportunity for New York Times to introduce a mobile-friendly app which can be used anytime they want. So now thank you very much for your time. This is all we had to do. These are the references used in the assignment. Have a good day. Thank you very much.